Okay, this is basically the first video in a long series of videos where I am going to try and explain my ideas and my philosophy about the genetic code. It's not possible for this to work in a short, well polished format. I'm going to treat this more like it's a semester long class because who hasn't had those? And we have to soldier on and fight through these damn boring lectures. And that's what I'm going to do is create a series of damn boring lectures. But that's really the only way to do it. Obviously, this is a low budget affair. Uh, it's not going to be polished. It's not going to be perfect. I'm just going to do the best I can to put my ideas out there so that people can hear them and talk about them and try and understand them and debate them because that's not happening right now. People don't, my ideas are not out there. They're pretty radical for the most part. Not all of them, but most of them are pretty radical. So there's people say, "Oh, go publish." Well, nobody will publish them. Say, "Oh, go have a conference." Well, nobody wants to hear it. They don't want to hear it now, but once they realize how terrible this current paradigm is and the fact that it can, will, and must shift, then everybody's going to start scrambling around saying, what are we going to do now? And the answer is, we're going to do this. We're going to take a very good, hard, serious look at my ideas because they represent a brand new paradigm for the genetic code that actually doesn't suck like the old one does. So we're going to go through it step by step. And so I think the very first thing we need to do is start with the basics. I was hoping that this setup would be such that I could write these notes and you could read them on the overhead, but that doesn't look like it's going to work. So we're going to be talking about science and philosophy and logic and math. So let's just start there. Let's keep it simple. That's one of my superpowers is simplicity. I'm very simple-minded. Comes in handy. And we're going to try and stick to that. So I feel like a lot of things are talked about and discussed and debated before they're defined. Well, how do you know what you're talking about until you define it? So if we're going to talk about science, philosophy, logic, and math, then I think we should define it. So that's what I'll do. I'll just do it real quickly. Science is the art of understanding the logic of the universe. Of course, wrapped up in that, this is the essence of science, but wrapped up into that is the implication or the idea that the universe is logical. Well, if it's not logical, then there's no science. Okay, people have these crazy ass ideas that science is a method. That's just bullshit. Okay, the scientific method is not the premise of science. The premise of science is that nature is logical, the universe is logical, and as men, we can craft a logical understanding of the universe. Now, if we need reinforcement of our ideas, or then we can go into the method, the hypothesis, the test, all that. But science itself is an art, and it's the idea that the universe is logical and we can find it. The next one is philosophy, which is the art of understanding the logic of understanding. Well, that's a good one. What that means is that there's an art to understanding logic, but then there's an art to understanding how we understand that logic. And they're inextricable. You can't separate the two. That's why there's a P in the letters PhD, which is a philosophy doctorate of science, because you can't separate our understanding from our ability to understand. So all science is based on a philosophy. That's what science is. Okay, logic is the art of reasoning between true and false. I mean, you can just say any crazy ass thing. What's the difference between this crazy ass thing and that crazy ass thing? The difference is that some things are true and some things are false. So logic is our method of determining true and false things. It's pretty simple, but it gets complex as you do it. That brings us to the last one, which is math, which is the language of compounding logic. So we take things that we know or believe or say are true, what we call an axiom, we say this is true, and we start compounding. That creates a language. Generally, we start with simple things like geometry, because what's simpler than geometry, right? So we say true things. We believe them to be true. Those are axioms or postulates. We start compounding them. Okay, this is how math works. It's a language. So it's common to hear the phrase that God is a mathematician. I believe that's a true statement. It combines all of these four things. So people say two sides of the same coin. Well, these are four sides. So I would say that we can see these four things, science, philosophy, logic, and math, as 4 points on a tetrahedron. Okay, they're in it. You can't break them apart. You can't remove logic from science. You can't remove math from logic. You can't remove philosophy from any of this. So that's my belief. I believe these things are simple and they're true. And this is what we're after here. We're going to try and reason our way through this stuff. Now, nobody just invented this yesterday. This shit's been going on for a long time. And a lot of the old stuff is the best stuff. So I'm just going to jump through some of the really old stuff. I'm going to start with number 2 here. Descartes, I think, therefore I am. Cogito, ergo sum. This is the basis of modern science, okay? There's a lot of stuff wrapped up into this. A lot of people interpret it in different ways. But the art of knowing requires a conscious, sentient, thinking being. I like to move this to the next level and say that the only reality is the reality that you're able to create in your head. These philosophies, they get complex and, we can go on forever. That's what philosophers do. But I think that for our purposes in this course, the idea that our brains, they basically create the only possible reality. And that does a couple of things. Number one, our brains are only simulations of reality. We generate these realities inside our brains based on the stimulus we get from something we consider to be objective. How much we can trust it, it's up for debate. But the idea to me is that we need to somehow compound, or there is a recursion involved here, where there's a reality that generates us and our reality, and we have faith that somehow these two are related. So I think this is, especially when it comes to the genetic code, I think this is major. When it comes to computers, which we'll talk about later, and the reality of the universe, I think Zeno, who had a series of paradoxes which modern man feels like he's solved, but I'm not so sure. But anyway, the basic idea is if I shoot an arrow and it's going to go from point A to point B, it has to go halfway, which is a discrete amount. Then it has to go halfway again. Okay, in mathematics, these are now known as power series. It's, the basis of calculus. We just wave it away. But I think in a sense of the reality of the universe, I don't think it's been resolved, and I don't think it's logically resolvable. I mean, the question comes down to the basics. Do we live in a universe that is discrete or continuous? And there's only three options. It's either discrete, continuous, or both. For reasons we'll discuss later, I don't like the idea that it's both, so we have to pick discrete or continuous. Well, the problem is that when you talk about reality, if it's discrete, well, it creates this illusion that it's continuous. But on the other side, if it's continuous, it creates an illusion that it's discrete. So, wow, how do we resolve that one? And then the one that's most pertinent to what we're discussing in this series is Thomas Aquinas. His quote is, "To one who has faith, no explanation is necessary. To one without faith, no explanation is possible." Now, this was hundreds of years ago. This is exactly true. It builds on the Latin phrase credo et intelligam, which means I believe in order to understand. I think this is the most powerful ancient thought because it's so true. I mean, for man, beliefs are way more important than knowledge or facts. You cannot comprehend or assimilate facts until you believe them. If you don't believe something's true, you can't comprehend it and you can't assimilate it. So this gets into the discussion that we're going to have about scientific paradigms. A paradigm is a model or a system of description. I call it a parable also. So science creates these paradigms which describe something. So let's just go through a few of them. The flat earth, well, that's obviously a paradigm. The geocentric universe, that's a paradigm too. What these really are is belief systems, okay? So we create this intricate system of belief, and then we create the language required to describe it. And there can be no thoughts or ideas without language, or especially any kind of transfer or communication or discussion of them. So these paradigms are incredibly important. They're very powerful. And so science gets very heavily invested in them. And they can go for a very long time and not change. You can't even challenge them. You become a heretic because you're challenging a belief system. And that's true. That's true in my case. I'm a heretic. And I'm very proud of that because it takes a lot of courage. It takes a lot of confidence. It takes a lot of patience. That's for sure. But anyway, I love being a heretic. That's what I am. I'm challenging a belief system. I'm challenging a scientific paradigm. Well, if we look at the history of scientific paradigms, there's a lot of bad ones, but there's never been one quite as bad as this one about a simple linear code of life. It's the worst one by far because we end up saying so many things that we know are false that are they're logically incoherent. I mean, it's hard to even say them because you're just making logical contradictions right and left. And empirically, we test them. We say, oh, this is true, but then we test it and it's false. It always proves false. It's the worst one ever. But they always arise in the same fashion. What happens is we get cause and effects mixed up. So, for instance, in the case of flat Earth, the cause of a flat Earth is you go out and you wander around and you make note of things and you put them down on a piece of paper. You come back and you discuss it with your boss or whoever sent you out there. You make a map. Clearly, the map is flat. It's not like, you go from point A to point B and then you go from point A to point C and that C and B wrap around. So the map is demonstrably flat. And it works. It works perfectly fine. There's no point to make it any harder than it needs to be. Your wanderings created your map, and your map creates your paradigm, okay? Same thing's true of a geocentric universe. I mean, it's pretty easy to see that we're not moving here on the Earth. The Earth is stationary, but yet stuff's moving around us. Okay, well, that's obvious. That's dead nuts obvious, and there's no reason to doubt it. There's no reason to change it. So it goes on for hundreds and hundreds of years, even though it's not true, even though at some level it doesn't make sense. But that paradigm is going to persist. I mean, we look back on it now and say, well, that's just goofy, but it's not goofy. These false paradigms are never goofy because they're useful for what they were intended to do. Well, the genetic code's the same way. They went out and found these molecules. They found this relationship between them. They made a map. They said these molecules are causing this relationship. These molecules are causing this map. This map is the basis of a code. We're done. Okay, that works for what it was intended to do. It got us started. It put us, on a certain path, but it's just false. Okay, it's not even close. But the thing that makes it so bad compared to a flat Earth and a geocentric universe was that those paradigms had some uses and they continue to be useful for a long time. But this paradigm of a linear genetic code has no use. It's useless. The only thing it does is it causes us to say things that confuse us. And so it's worse than worthless. We'd be better with no paradigm at all. Fortunately, we're stuck with this one. So before we can move forward and actually have rational discussions, we need to get rid of this paradigm. And that's not so hard to do. We'll do that, pretty definitively a little bit later. So then, once we've gotten rid of this hideous piece of garbage, the question is, what next? Well, we need to invent a new paradigm. Well, that's not so hard to do either. And actually, that's what's fun. And that's what science is all about. So in our next video, we're going to talk about inventing anything, really, but especially inventing paradigms.